In this lesson, we are going to look at how to model and work with simple information. Before proceeding, please open up your preferred IDE or online editor, as I fully expect you to follow along with me by writing out the code examples. In the previous video, I used a debugging tool called a stepper to look at the state of my variables as they change during runtime. There is also a simpler and faster way to do this. Every running program, also known as a process, is constantly communicating streams of data between itself and the operating system. Using the system.out.println method or command, we can make use of one of these streams to print out textual data to a console or terminal. If you're not sure what a console or terminal is, it is the simplest way in which a computer and human can interact, via text. The most common type of variable we use for textual data is a string, which you can think of as a sequence of char primitives. String is a reference type, and most reference types require usage of the new keyword, unlike primitives. However, because string is used so often, even a verbose language like Java will allow you to cut some corners when creating them. Alright, now we will call the system.out.println method and give it our variable. Assuming your code is well formed, if you were to run it, it would print "Hello World" to the console. One last change. As programmers, we always want to write the minimal lines of code and use up the least amount of memory as possible. If we wanted to, we can actually get rid of our variable entirely and just type our message directly into the arguments for println. Now we will play around with some numbers and simple math. Let us create two int variables. Now we will perform subtraction of them and store that result in another int variable. Now we will print out that result. Everything looks good, but let's try some division. Because we are using int-type variables which do not support decimals, our divide result was rounded to the nearest integer. Let's make a few changes so that we are printing an accurate result. Now let's run the example. Much better. Now we will look at a practical problem. Pay close attention, as there will be a coding exercise I expect you to complete at the end of this lesson. Every program needs to have a starting point for execution. In Java and many other C-based languages, that starting point is a main function. Notice how if you change the main method in any way, the IDE will no longer allow it to be used as a starting point. Also notice that main accepts what looks like a string type, but there are some square brackets beside it. These square brackets can follow any primitive or reference type, and they indicate an array structure. Let us create an array to learn more about how they work. Great, now we are going to make the elements at index 1 equal to 2. Alright, now here is a trick question. Did I just set the first element in this array equal to 2? Once again, I am going to use the debugger to get an idea of what an array looks like under the hood. As you can see, this variable called integer array is associated with 4 different cells, or you can think of them as buckets full of data. Now let us execute the next line and answer the trick question from before. The answer is no, I did not set the first element in this array equal to 2, but rather the second element equal to 2. That is right, the index or location of the first element in an array is 0, and the second is 1, and so on. It is perfectly natural to be confused and even annoyed by zero-based indexing, but you will have to get used to it. There are legitimate technical reasons why this kind of indexing is preferred in arrays, but that is a topic for a different course. We are now going to combine our knowledge of int primitives and arrays together with a very useful programming construct. As you may have noticed, when I use the debugger, a program is executed in a line-by-line, top-down way. Keep that in mind as we take a look at this new construct called a for loop. I am going to ask you to type along with me here, and after that I will explain what we just did. Now normally we leave this all on the same line, but I am going to break this for loop up so that we can add some notes to different parts of it. The comments I just wrote explain what each part of a for loop is responsible for. In order to see how they work, let us once again use the debugger. A programming loop allows us to repeat or iterate a block of code. We can also modify the variables in the loop after each iteration. In this case, we have stated that we will add 1 to the index each time. Let us step through a few iterations so that you can get an idea of what's going on. As you can see, we are just printing whatever values are stored in this array for each index. Before we proceed, there is one more thing about arrays that I want to show you. Suppose that the indexes of an array represent a coordinate which we will call x. It is actually possible to add more coordinates to our arrays and thus create a multi-dimensional array. We will now create a two-dimensional array, which is quite easy to do. The main difference here is that when we want to assign a value to an array cell, we must now supply what I will call a y value as well. Here's a simple coding challenge. Using what you know about array indexing, I want you to make the cell in the third column of the third row equal to 5. Pause the video now and give it a try. Be sure to actually run the code to make sure that you do not have any errors. Alright, if you wrote this, then you have the correct answer. Otherwise, you may have become another victim of zero-based indexing and been given an array index out of bounds exception. To be honest, even after 6 years of Java, I still forget this from time to time.